How does an AI know what the word it is pointing at? One number, computed for every pair of words. Change one word at the end, tired becomes wide, and the same pronoun now points somewhere else entirely. Nothing else in the sentence moved. By the end of this, you will have built that in 8 lines of code. Quick map before we start. This whole series is one paper from 2017, 8 pages that quietly rebuilt AI. It breaks into 5 pieces. The attention mechanism itself, then scaling and multiple heads, then how the model learns word order, then everything wrapped around attention, and finally how it writes a sentence. Today is piece number 1, the mechanism. Get this, and the other 4 are variations on it. And here is the machine that paper describes. Do not panic, by the end of the series every box here will be something you already understand. Words come in at the bottom and become vectors. Where those vectors come from is a whole story of its own, that is episode 1.1 and a paper we will cover later. Today we take them as given. Position gets added on. Then the tower on the left, the encoder, stacks attention, a normalized step and a small feed-forward network, repeated n times. The tower on the right, the decoder, does the same, plus a masked attention and one that reaches across to read the encoder's keys and values. And at the very top, a linear layer and a softmax turn the final vectors into probabilities over the next word. Now watch. Every box on this diagram is a future part of this series. Today we open exactly one of them, this one, multi-head attention. Everything else is built around it. Here is the problem every language model has to solve. This word means nothing on its own. Put a river next to it and it is a muddy slope. Put a robbery next to it and it is a vault full of money. Same letters. The meaning came from the neighbors. So a model needs a way to build each word's meaning out of the words around it and to decide which neighbors actually matter. Episode 1.5 gave us the tool. Two vectors pointing the same way have a big dot product. Swing one of them away and the number falls. At 90 degrees it is 0. Point them apart and it goes negative. One number that says how much these two agree. That is the entire scoring mechanism. Everything else today is bookkeeping around this one number. You have already written this. It is a hash map with one line changed. If you have ever written a hash map or a dictionary, you already know most of this. Keys on the left, values on the right. You hand it a query. It walks the keys, tests each one for equality, and hands back the one value that matched. Now ask it for the word it. Nothing in the table equals it, so the lookup throws. And that is exactly the problem language has. The word you want is never spelled the same as the word you are holding. So change one thing. Replace equals with a score. How well does this query match this key? The dot product we just built. Every key gets a score and the scores are squeezed so they add up to 1. Nothing is ever missed and nothing ever throws. Then instead of returning one value, you return all of them, mixed in those proportions. 61% of the animal's value, 2% of the streets, and so on. That is attention. A dictionary lookup that never misses, because it answers with a blend instead of a match. The query, the keys, the values. Those are the real names, and you have been using them for years. Walk into a library with a question, that is your query. Every book on the shelf advertises what it is about, that is its key. You compare your question to each spine, and you walk out with a blend of the books that matched. What is inside those books is the value. Now the one idea people get stuck on. A word does not just sit there as a single vector. It is multiplied by a first learned matrix to make a query. What this word is looking for in the others. A second learned matrix makes a key. What this word advertises about itself to anyone asking. And a third makes a value. What this word actually hands over if you decide to pay attention to it. Query, key, value. 3 different jobs, 3 different learned matrices, one word. Hold on to those 3 names, the rest is arithmetic. Here is the query for the word it as 6 actual numbers. Notice it is almost all 0 except one slot, the one that means tiredness. This vector is literally asking, who here can be tired? And here are 2 keys. Animal advertises a 1 in the tiredness slot. Street advertises almost nothing there. Its big number is in the width slot instead. Here they are lined up. 6 numbers against 6 numbers. Multiply each pair straight down the line and keep a running total. 0, 0, 0. Then 1 times 1, there it is, 1.00. And the last two are 0 again. Now swap in street and run the exact same 6 multiplications. 1.00 against 0.05. A 20 times difference. And every step of it is arithmetic you just watched. That gap is the whole reason the model picks animal. Let us do it for real for the word it with every number on screen. Take the query for it and dot it with the key of every other word. That is one number per word, a raw score. Now push them through a softmax. Big scores stay big, small ones shrink toward nothing, and crucially they all add up to exactly 1. These are the attention weights. Look at what it decided. Animal 0.66. Everything else almost nothing. The model has resolved the pronoun. Last step. Every word also handed over a value vector. Here are two of them. Multiply each value by its weight and add them up. Animal counts for 2/3 of the answer, street for almost nothing. So the answer lands right on top of animal. That blended vector is the new meaning of the word it. At a loud dinner party, every voice reaches your ears at once. You do not mute anyone. You just weight the one person you care about far more heavily than the rest. And that blend is what you actually hear. We just did that for one word. Do it for all of them at the same time by stacking every query into a matrix, Q, every key into K, and every value into V. Q times K transpose is then one grid, every word scored against every other word. Bright means pays attention to. And there is the row for the word it, one bright cell, sitting on animal. Swap that for wide, and the bright cell slides along the row to street. That is the whole trick of the hook, and now you know exactly which numbers moved. The bee landed on the flower because it was sweet. Sweetness belongs to a flower, so it points at the flower. Change one word to tired and it swings to the bee. Same formula, same weights, machinery, new answer. Another one. I put the book on the shelf because it was empty. Only a shelf can be empty. And heavy sends it back to the book. You are watching one equation. Resolve pronouns it has never seen. Let us actually run it. 4 lines in a terminal, the projections, the scores, the softmax, and there it is. The word it attends to animal with weight 0.657, the exact number you just watched us build by hand. Everything so far was our own toy model, built so you could see every number. So, does a real one do the same thing? This is DistilBERT. 66 million weights, trained on real text, downloaded, not built by us. Here is what one of its attention heads actually puts on each word when it looks out from the word it. 0.61 on animal, 0.02 on street, 29 times more weight on the right noun, and nobody ever wrote a rule telling it to do that. But be careful with that. This is one head out of 72 and only 10 of them rank animal first. The others do not all agree. Some ignore the nouns completely. Why a model needs that many and why you cannot read a single one as its reasoning is where part 2 begins. So how much does the word it look at the word animal? 5 steps and every number is on the screen next to it. Step 1. Each word carries 64 numbers. Multiply them in pairs straight down the line. 0.205 times minus 1.849 is minus 0.38. Notice it is negative, some pairs pull the total down. Then 61 more. Add all 64 together and you get 59.764. Step 2. Divide by the square root of 64, which is 8. That keeps the number small enough for the next step. 7.47. Step 3. Step 3. Exponentiate. Animal happens to be the largest score in the row, so this one comes out at exactly 1. Step 4. Divide by the total across the whole row, 1.6448, so the 16 weights add up to 1. And out comes 0.6080, which is exactly what the notebook on the left printed. 5 steps, no magic. Our toy flipped cleanly. Watch the real one refused to. Our toy did something clean here. Change the last word and the arrow jumps straight from animal to street. So watch the real one do it. Tired becomes wide. Street does blind, 4.5 times more attention than it had. That is real, and it is in the direction the textbook promises. But animal is still 0.26 and street is 0.09. Animal still wins. The attention shifted. It did not switch. Only 8 of the 72 heads flip outright, and this is not one of them. And look what it actually leans on hardest. The adjective itself, 0.32 on the word wide. One head is doing part of a job, not the whole job, which is exactly why the paper runs 8 of them at once. One thing should be bothering you. The word tired comes after the word it. So how did the model use a word it had not reached yet? Because there are two kinds of model. This one reads the whole sentence at once, in both directions. That is an encoder. A GPT is a decoder, it writes left to right. So, when a decoder reads the word it, the last two words have not been written yet. They do not exist, which gives us something we can actually test. Run both sentences through GPT-2 and compare what the word it looks at. If the last words really are invisible, the two rows must come out identical. Not similar, identical. 0. Across 12 layers and 12 heads, the biggest difference anywhere is exactly 0. Byte for byte the same. That is why ABERT reads and a GPT writes, and it is one line of code you can run yourself. 8 lines. Project the words into queries, keys and values. Score every pair with one matrix. Multiply, softmax the rows so they sum to 1 and multiply by the values. That is attention. The notebook is in the description. One screen, the whole thing. 1. The words come in and each one is a vector. 2. Every word is multiplied by 3 learn matrices, giving it 3 rows, a query, a key and a value. 3. Every query is dotted with every key. One number for every pair of words. 4. Softmax turns those numbers into weights that add up to 1. 5. Multiply the values by those weights and add. Out comes a new vector for each word, the same word now carrying its context. And that entire picture is the one line we started with. One part down, you now have the mechanism itself. If you remember one sentence from today, make it this one. Attention is a weighted average of values and the weights are dot products. But I left something out. The real formula in the paper has one more symbol in it, a single division. Without it, everything you just learned falls apart the moment you run it at full size. That is where we start next time. Next, run this at real size and it breaks. One division fixes it and then we run 8 of these at once.